Thank you, sir, for that insightful presentation. Now we will begin our panel discussion. I would like to invite all the speakers on stage, along with Lata ma'am, Subramania sir, Kande sir, and Vinod sir. So we'll begin with our panel discussion. I'll open the forum for delegate questions, so the audience can go ahead and ask their questions if they want. Yeah, over there. Can someone please pass the mic?
Hey, hi, good morning. Good morning, everyone. I think great discussions, and I have a question to Vinod, sir. So I work for Dow. My name is Archana, and we adopt a lot of your ABB solutions. My question is, I think I'm glad that you touch based on the engineering data, right? Giving a end-to-end solution, right? Everything starts with engineering, and then it goes to operations, the process automation and all that. So my question is, do you have any solution in ABB that would transform your legacy PNID data? Because that's becoming a major problem, like owner operators. We have legacy PNIDs, and that's in a very old format, but still we have to adopt to the AI solutions. So my question is there any solution that ABB can offer for end-to-end transforming the PNID data?
Yeah. Yes. Yeah, thanks. Thank you for that question. So typically what happens is when you have traditional PNID data and solutions out there, we take that and convert that into a particular format. Maybe it could be just a simple PDF format and other things, and try to even create an SVG file and then upload that into the system, and then ensure that you have capabilities of operational data bitting on top of it, which actually translates that PNID diagram into a twin, a crude digital twin, and ensuring. So to answer your question, we don't have a direct uh, solution out there for all the PNIDs out there, but if you are already on a standard system, then we can try to convert that easily.
You mean standard system of ABB?
Yes.
Okay, thank you.
Yeah, can you pass the mic to the gentleman in the second row?
I have two questions. In your presentation, Madam, you presented 4D. What is the fourth dimension? Time, is it?
Yeah, it's time.
So, along with 3D, time is also there. So, there are time dependent changes are captured, is it?
Yeah, it's basically time dependent changes as well as the planning and scheduling.
Mic is not working.
It's the planning and scheduling as well. Sometimes what happens is during the course of a project, we would have planned a specific schedule, say for a duration of 6 months. Due to some reasons like approvals or delay in procurement of equipment, this could delay a bit. Then instead of redoing the entire planning and scheduling, we can shift the baseline so that other parameters are maintained. And in case we need to fit in the balance portion within the 6 months duration, the total duration of 6 months, we can try to squeeze in the data so that our engineering deliverables are done at a much faster rate.
Sir, the other question is to you. Uh, in the rotating machinery, wireless sensors, where are they located, sir? Wireless sensors on the rotating uh, plane or on the fixed plane?
Yeah, it's on the bearing housings basically. These
Rotating
are
plane.
triaxial sensors actually. These are so
Because
it takes.
on the rotating plane, the centrifugal forces may come in, and the data you collect from wireless sensors may. How do you integrate up the data in your control room? How do you really manage, like
like how basically this wireless, so there are the routers, wireless routers are there, and then it goes to the router collecting the data from the wireless sensor. There is a unique identification is there, so it gets the data into the through router, wireless router to the server finally, and then from server, once it gets to the server through cloud, anywhere you can get it actually. That's how it is done. The architecture we have done, it's a very long, there are many switches, servers, many are there actually. So that's how it is collected.
and the wind energy systems, huge turbine blades running into meters. The same concept can be applied to monitor the wind turbines in the control room remotely.
Yeah, it can be done, yes.
It's possible.
It's possible.
So maintenance and diagnostics, prognostics can be done.
Yeah, definitely.
Yeah.
Thank you.
Can we move on to the next? Yeah, the gentleman at the end. You want to ask a
Yeah.
question? Yeah, please.
My question is directed to Madam Lata. See, you said you have AI tools for here. AI tools for mining and metallurgy and all that. Do you have any AI tool for geological survey? Because we had some news that lithium deposits are available in Jammu and Kashmir and all that. Since we are totally dependent on China, 70% of them come from China only. So is there a possibility that you have certain tools for geological survey?
Sir, as on date, we do not have any tool for geological survey, but definitely we can develop.
Okay. The gentleman at the end, can we pass the mic to him? I'll come to you, sir.
Hi, this is Gaurav from ExxonMobil. My question is directed to Mr. Vinod. So you talked about how the new generation AI is going to be a combination of first principle and also the LLM models or the AI models, right? Historically, we have seen that the OEMs have been developing those first principles or their technologies in silos. And then you also talked about scaling it through patterns and not just by projects. So if we as end users, if we are developing some AI, say at ExxonMobil, it's going to be based on data just for ExxonMobil. Vis-a-vis OEMs are going to have larger visibility across the world. Is there a call for action between the OEMs to kind of integrate the data across multiple OEMs, because that's going to make the AI models more stronger? So is there a call, and if not, do we see such a call in future? And maybe not just to ABB, but this question is to all the OEM representatives in the forum.
Thank you. Thank you for your question. When we talk about OEMs and the domain-specific models which they have already created, I would completely agree. If it was an ideal world, we should have some standardization across these OEMs, and that will help us to bring an simple ensemble model on top of it, combining the data-driven AI along with the domain-specific. But unfortunately, that's not the case. So typically what we do is in the real world, we try to use the physics-based model. The outcome of that is fed into the AI models, and that is based on that we will be able to create a proper ensemble and derive the outcome. But if you look 20 years before, there was no need of doing this actually, because the output which was coming was more or less accurate, and it was more quality enabled at that time. But with the advent of disparate source systems as well as sensors which has come into this world, and thereby, in fact, the accuracy has gone down maybe by 2%, 3%. That is where you need to have such ensemble models, and this also takes time to come into that training level and to bring that accuracy as as the past and ensure that you get the right output. So I agree, if there is a consortium which actually helps you to bring some alignment across the OEMs and get that, that would be really good.
Okay, can we pass the mic to the gentleman wearing the hat?
Thank you. First of all, big thanks to all the speakers, very informative. And what I loved especially was the very practical inputs which all of you shared and the generosity with which you did. Particularly liked what Mr. Ninan said, is something which was always on my mind when he said his end slide. You have to scale by patterns and not scale by pilots. This is actually a question to all three of them, if you can indulge us. Automation, as we all know, is not just about workflow, but it's more about behaviors and adoptions by the human being on the ground. So the question is, what is the area where you find specifically maintenance engineers distrusting an AI output? What is that area where they find, I can't trust this thing which is coming from an AI black box? And in your experience, how have you gone about convincing them?
Maybe I can start. So if you go into any of the customers these days, the first answer would be a resistance that we don't have this. So in that way, you're right. So that we need to have some capabilities, and that can happen over a period of time. One is, I would say that, as I mentioned, we need to ensure that we have the right contextual intelligence in place. Then, based on that, you need to run the different AI/ML models. On top of that, you need to have a proper, I would say, really human in a loop agentic AI model, which can help you to ensure that the confidence in a shop floor person or an operator or a maintenance person can happen over a period of time. I think there is no quick solution out there. This is something which will take some time.
I would like to add up on that. I think currently we are using AI extensively from point of view based on the requirement. Like in case of rotating equipment, basically static equipment, though AI applications are limited. Whereas when it comes to design engineering, we have a lot of challenges. Like possibly I'll make a PNID using AI, then like I may not be knowing the exact process. The AI could generate a drawing, but it would not be able to like calculate the drop across a wall or something like that. So there is a lot of data to be inbuilt into the system, which definitely takes a lot of time. And the second concern is the compliance to the statutory and regulatory requirements. These requirements, even if I try to build into the system, they change over a period of time. So uh, there is a need for constant updation of this too. Thank you.
So do you have any additional comments on this?
Yeah, we are not gone to that stage actually. We are not directly, it goes through the human interface, and so human knowledge is always there, our expertise is always there in the loop actually. It's not directly any input going to the either operation engineer or a maintenance engineer, which we don't want to do at this stage because we are not matured to that level that, AI can take over the entire thing actually. So but I agree with him actually. Near future is not going to be a lot of contextualization and a lot of expertise is needed. We are trying to build this, models actually, but it's maybe 60-70% accuracy still at this stage. So there is a challenge actually. But in future it may happen actually, but definitely not 100% is not going to happen. That's why, because every machine is unique and its operating environment is unique, and its behavior patterns are totally different actually. So you don't have a very unique solution for all these things, and it's going to take, I don't know how far it will take, but something is, behavior can be predicted and it is consistent, then you can really apply the AI, and then you can directly you can give the recommendation or action to the operations, or but in refineries and all, the safety and these are very, very primary importance. Actually, it's some wrong decision. For one thing I wanted to share, the alerts which come from the sensors, I found 20% are fault signals. So we'll have to keep it in mind every time the measurement. Don't believe that the measurement, what is coming from the sensors is really accurate. Actually, it's not. So you'll have to filter out all those things, which still, the AI agents, whatever we developed, is still not able to do that actually. So the person is human interface, engineer intervention is required actually at this stage, I can say.
Okay,
Yeah.
thank you. Oh, sorry, ma'am, you want to add
Okay,
something?
to
Yeah.
add on to that, right now AI is in a very nascent stage, possibly in the case of semiconductor manufacturing plants, the solar PV cell manufacturing. We have implemented AI to a certain extent, wherein very few people are required to be in the factory. And of course, these are referred to as dark factories because even the lights are switched off and the machines keep working. Whereas in the case of hazardous area applications like refineries, it's a long, long, long way to go. Thank you.
Okay. Sorry, sir, we have run out of time. We have to end the panel discussion here. If you have any further questions, you can always connect with them after this session is over personally. Well, thank you so much
Thank
to
you.
all three of you. That was a wonderful session.
Thank you.
Just